doesn't work either. All right. Anyway, I'm gonna start. Okay, everyone, welcome to today's class. And starting from today, we're gonna talk about software security. So we're gonna learn, some interesting vulnerabilities, the way that you can hack a vulnerability, like you can hack a program. And also we're gonna learn some, fundamental skills of like reverse engineering and, hacking. All right, so I know that some of you already have a great background in terms of like C, C++, but some of you don't. So in this class today, we're gonna mostly just recall what you have learned before in terms of C or C++, as well as a tip for Python, since you're gonna be dominantly use Python for software security assignment. So I'm gonna give you a quick Python 101 as well as a C and C++ 101. But it doesn't mean that this is the whole, like everything that you need to know for Python or C in order to ace this class. So this is more of a teaser. And for this, if you still feel that you need to catch up more, I will encourage you to spend more time, after hours, so that you will be able to more familiar with C++, Python, and that will help you for your future assignment. Okay, so yeah, as I said, today we're going to talk about three stuff: C 101, Python 101, and then also endianness, which is rooted from binary and hexadecimal numbers. All right, so first C. Let's start with this program. So can someone tell me what is the output of this program? Yes. Yes, exactly. So the output would be, book one's name, Harper, and then philosopher's stone, and then a new line, like \n. Okay, then what about this program? As you will see, this program is pretty similar to the previous one, but it has some tiny little difference. Anyone has an idea?
I think I have.
Actually, no. I'm gonna wait for another answer. Yes. Sorry, say it again. I can't hear. Right. And could you explain why is this? Mm-hmm. Mm-hmm. I see. Yep, you got the answer correct, but the reason is not quite right, but at least yeah, but it's very close. All right, I'm also checking chat. We said that everything is still null and no address for Harry Potter book. Right, so here's the thing. When we have init2, right, and then we pass this parameter, which is Harry Potter 2, as an argument of this function. And here, the type of the argument is book. And the way that C works is that it will copy this parameter. Sorry. It will copy this parameter, as the argument of this function init2. And then it will change the value all over here, but then this book here, because it copies the value, it doesn't really refer the value to the exact address that Harry Potter 2 resides. So that's the reason why here when we have init2 with Harry Potter 2, this book is different from this Harry Potter 2 book. So for no matter operations that you do in this function init2, it doesn't really affect the value of Harry Potter 2. And hence, when you print Harry Potter 2, it will keep the original value, just like you have never done anything about like init2. And that's why here it will have an empty string and it will just output, only those part of the string, and Harry Potter 2.name is still remain empty. However, you can change this slightly in order to make it, output the right value, which is the, chamber of secret, that expected value. All right, and then this is gonna be a question for you guys. In order to call the function and also define function init3 property so that we can output the book of the name of the book, how you should pass those parameters in and how you should declare the type of the parameters in a function. Yes. How? Can you be more specific? Mm-hmm. Yep, right, exactly. So in order to output the proper value, what you need to do is you just pass Harry Potter 3 here to init3, because here Harry Potter 3 is no longer a book, it's a book pointer. Okay, so you just pass Harry Potter 3 here, and then when you declare the function init3, you should pass you should define the argument as a book pointer instead of a book itself. In this case, that we will be able to edit Harry Potter 3 directly because we passed the pointer value, which is still going to copy there, but it's going to be the pointer value which is the address, of the original Harry Potter 3 book. And then you will be able to change the name and author's value, and then you'll be output the name of the book property. Okay, so this is just like a very little tiny part of C, and the reason why I want to bring this up is because in our future, lectures, when we talk about like memories, when we talk about like different kinds of vulnerabilities, it's all about memory operations. So you should be able to understand like pointer or reference and like a argument passing into the pointer, argument passing to the function, how that works. And that will give you a better mind when you, figured out when you identify those vulnerabilities. Okay. So next part is about Python. So we're gonna have a very like a small demo in terms of Python. And actually for this, we can work on this together. So if you have a laptop right now, feel free to open it up. And especially that, if you have a Python installed, it will be even better. We can program this Python, program together, and then try to, write an interactive server, and also, write a small client that can interact with the server. All right, and now I'm gonna give you a couple more minutes to set up your equipment, and then we're gonna start.
Excuse me. Hello? Hello, Professor?
Okay, guys, now let's start to write this server together. So what we're going to do is very easy. Let's just write a server that will take input from the client who's going to interact with it, and then just output the message that the client types in. All right. And we're going to do that first, starting from Ascii in and Ascii out. So basically, you don't need to care about the socket. You don't need to worry about network connection, etc. Let's just start with simple standard in and standard out. All right. So I'm going to create a file just called server.py. First, just write the kind of like placeholder that will call a main function. Okay, so in this case, the program will, if the program was called directly, it would call the so-called main function. And then in this main function, we are going to first write a welcome message, and also takes the message that coming from the client, which in this case is standard in. So we could use this input function and write our welcome message over there. Okay. And when we call function input, it will output this string and takes the standard in's input and then store that in MSG, like in this variable. So basically, this input function will return the string that coming from the Ascii in, and also it will coming, it will stop when the Ascii in hits an enter. Okay, so you can consider this as like you output a message and then read one line from standard in, which is gonna be the message. All right, and then you're gonna, let's just print the message out. Okay. All right, and that's it. It's very easy, right? And now I'm gonna just put the shebang here so that I can just run this program directly instead of calling a Python 3. So I redirect that. I need to make it executable. Okay, so now we have a server. We call it server, but actually just like read the standard in, right? And then we just put some random message up there and we output those random message. That's it. Very straightforward. So far so good? Or do you want to see the server program again? Okay, so now let's continue to write a client. And for this client, what it's going to do is it will interact with the server. And this client will also, try to talk to the server or invoke the server so that it can talk with it. And here we're going to use a package called Pong tool. So if you haven't installed Pong, you can install it now. So it's gonna, Pong2 is a nice package that you can use to basically for a lot of CTF challenges, especially for binary analysis and reverse engineering, like Pong and reverse engineering. And we're also gonna use it dominantly for our assignment. I think it's very convenient. If you're gonna decide to use Python to program for assignment, using this package will be doable and it will be very helpful for you. Yes. I think it's already automatically installed in Pong College.
It is for
Yeah, for Pong College, right? Thanks for confirmation. Yep, so it's already there. All right, so now let's start to write this client. Again, I'm gonna put main function there. And then start to write the main function. Okay, so the first step is that we are going to call the server, because in the future when we have those challenge, you need to call the challenge. If you remember in Pong College, right, you always need to call the challenge, run the challenge first, and then interact with it. So here also we're gonna call the server and then interact with the server. When we call the server, we're gonna do R is equal to process. So we use this process function coming from Pong2. So we tell the process that, okay, we create a process which calls server.py, which is the the program on the left-hand side. Okay. And after we initialize the process, we now want to interact with them. So what we could do is we just send a line with a message that we want to talk to the server. I'm going to write something here. Hey, server. And if you remember, if we write a, like hey, server here, we will get another line, right? So this is what the server responded to us. And here in our client, let's try to receive that message. And later on, you may be able to do further operation. So then after we send a line, we want to receive one line from the server. We can use function called receive line. Okay. And it will output the line that we receive from the server, and we can just bring it. Okay, and I saw there's questions online asking, where does this underscore name get defined? So that is the built-in coming from the, coming from the Python, coming from the program. Basically, what Python, like the interpreter, what it does is that it will, when it starts to execute the program, the -- name will be set as -- main. And then now what we're telling Python is that if the current execution is -- main, then you want to start with the main function. Okay. I mean, you could also potentially, just do, main like this, but I just try to make it more structured. I usually prefer to make it more structured. And also, if you just do main directly, whenever you say you include this as a module, for other program, that you will still call main, but that is not something that you want to have if you consider this file as like a library, right? Like a package. So instead, you want to have this specific line, meaning that main will only be called when we use Python to execute this program directly. All right, so now let's try to run client. Oh, similarly, let's add the Shaban so that we can run it without like typing Python. That would just be more convenient. So like this. And also because you're going to execute it directly, right? So you need to enable yourself via execution permission. So that's why you use change mod plus X means that add execution permission to the file. And now you should be able to run client. Okay, so now my Python's telling me that I haven't installed the module called Pong. Let me enable another virtual environment. I believe this one has it. Nope. Okay, so I don't have it, but I can just let me install it right now. So if you're gonna also install this, you could do it just Pong tool, pip install, Pong tools. It's already there. Here we go. Okay, now it should be fine. Oh, I know the problem because I am specified that to the run Python 3. So I need to do env Python 3. Yep. Okay, let me clear this up. So what I did here is that when I use virtual environment, I cannot just specify Python as user being Python 3, because in that case, it will go to the system's original Python. So instead, I need to have in Python 3 that will direct me to the correct virtual environment that I already installed in the system. Okay, so now I'm using my virtual environment, and then with the right specification, I can run client. So it says that it output this as a byte, and then it stops the process. And you see that here says that the text is not the byte, assuming the ASCII. So you want to make sure that if you're using Python 3, you want to add a B there. It means that you're sending a byte instead of a string to the server. And now you see that the warning message is gone. All right, so this is like a special like a feature or say a change in Python 3 comparing to Python 2. So they're gonna have dominantly using bytes instead of a string. If you're not very familiar with string and bytes, you can just like Google Python 3 bytes and it will give you more information about that. But for now, all you need to know just like whenever you use like send lines or receive lines, the type that it returns or the type of the argument that you send to should be in bytes instead of in string. Okay, so that's everything about the client and the server. And remember that I said we want to make it as a true server, something that is really running as a server, listening to the port, and then a client can interact with it. So how can we make a standard in and out program? Make that as a server that is listening to the port and interacting with potential clients. In order to do that, we can try two different kinds of commands. One is called xinetd, and the other is called socat. So for xinetd, what you need to do is that you need to have a configuration file. Xinetd will read that configuration file and then execute it. I am going to just copy the configuration file here, and then we can take a look together. So here, my cursor is pointing to the configuration file. It specifies the protocol, the socket type, and also the user when it is like the server is run. Actually, the user when client connects to it, and then it specify where the user, where the server is, the program. For example, this one is the program they're going to use as the server, right? So we're going to specify the path of the server, making that, as the program that will run binding with the port, which is here specified in the last line of the service. Okay, so from this configure file, based on that, we will use XNetD to run the server program and then use that to listen to port 6666. All right. Okay, so based on that, let's run it. The command will be sudo xnetd -f, which is to pass this configuration file to xnetd. And you can also specify, the log if you want to log into generate log and see what's going correct or wrong while you're running the server. All right. Okay, now let's connect to port 6666. And we're going to use netcat command. So we do local nc localhost 6666. All right. So here we will have that server that running, and we can just type whatever we have. All right. So that's everything about running the server. And there is another way that we can run the server, which is to use socat. So for socat, what you could do is you could have socat TCP4 listen, and let's say 7777 reuse address fork and execute the server. Okay, and now it's working. Again, let's use netcat to connect to the server. And we can see those messages coming out. So the server is running right now. Okay. Okay, so now we have the server property running. And the next that we're going to do is we want to have our client to connect to the server. But if you remember, let me just open a new tab and look at the client that we just wrote. We're not really talk to the server, right? So the client was just calling the server and interact with it. So we want to change this. And the nice thing for Pong2 is that it already provides us a nice feature that you can just remotely connect to the specific address and the specific port. And all you need to do is just change this one line to another line, which is use remote function and pass the address here. I'm going to use localhost because I am running it locally, and the port. Okay. And now I'm going to run the client, right? So you see that we are, outputting the value, outputting those lines from the server. And you may wonder that, this is the welcome message, right? This is not the response coming from the server. All you need to do just like print 2 times off the line. Oh, interesting. Now we get an error. Oh, it's because it's already closed. Yep. Okay, so hey server, it's here. Hey server is the message that we sent, and input your message is the welcome message that we get from the server, right? So we actually have both the welcome message and the message that we type over there. All right, so that's the interaction for client, remember that all you need to do, just change it from calling the server locally to remote connecting to the address with the port. So far, any question? All right, if not, I am going to change it back to the slides. And again, you will have the slides online, so you don't really have to remember those commands. I already put what you need to know, like in terms of how to run the server, the configuration of the server over here in the slides. So you can just get that directly. Again, you need to have a configuration file if you're going to use AxeNetD. But you can also just use SOCAT that will directly, run with the argument instead of passing a configuration file. So question here, where is service.conf? So service.conf is this file. You just need to copy paste this and then save it as a service.conf. And also you want to change like the path of the server that you want to run, as well as the port. In that case, you can use AxeNetD to run the program as a server. Okay. So those are what I just talked about is the the way that we can use Python to run program, and you are probably going to use that very frequently while you're doing the software security assignment or participating like CTF challenges. Participate CTF and working on those challenges. Okay, and then now let's start to talk about a different part, which is about byte and endedness. Can someone just tell me, have you heard about endedness, or is this already covered in previous, like the courses that you have taken before? Anyone know about endedness before? One? I see. Okay, yeah. Our Zoom student says that Adam covered it last week. Good. So we do have some, background about endedness. Then it's great. So I am going to try to recall you, or just I say to repeat what we have, what you need to know for in terms of endedness, because for that you will use it a lot when you like understand the memory layout and when you figured out the right byte, the right inputs when you hack a program. All right. So let's first start with bytes, or say binary. All right, so we all know binary, right? It's 0 and 1, that's it, it's binary number. And then when we look at program, it's just like a bunch of binaries. That's why we always say binary analysis, it means that you are looking at the program without any source code. So that's why when you look at the program itself, there's a bunch of zeros and ones. That's so-called the binary. But binary, it's a very little tiny unit, right? It has only one bit, either 0 or 1. And usually for computer, they don't consider that, they will think that this unit, the bit is too small. But instead, for memory, they will mostly consider everything from a byte level, which is slightly larger than a unit of binary. So byte is 8 bits, basically. So everything like a single unit, when we talk about x86, 64, or x86, when we talk about those memory, everything takes bytes as a single unit. So that's why, for example, we have character. Each character is 1 byte, and that's the minimum unit when we talk about memory. Okay, so suppose that we have a number, okay? We have a byte. How are we going to represent a byte? So for example, if we have a byte like this, so it's just like 10101100. So this is, as I said, 8 bits, right? And in this 8 bits, this is a number that we have. How are we going to represent a byte number? So we want to put this as 8 bits. And this is the lower, like the least significant part, right? And this is this is the most significant number. And if we talk about the position, we can start to label the position from 0 to 7. All right, so now we have 8 bits over here. We're gonna first divide this 8 bits into 2 parts. So each part has 4 bits. So that means it's a hexadecimal, right? And then for that 4 bits, we're gonna convert that to a hexadecimal number. For example, here, for the higher part, the 4 bits are 1010. And therefore, the hexadecimal number is 8. Similarly, for the lower part, the 4 bits is 1100. And the hexadecimal of it is C. And then we just combine these two together. We will represent a byte as 0 hex AC. So it's like 1 byte looking at the higher half and the lower half, and then combine them together. We'll have this representation for the byte. And we're going to use it very, very often in the future assignment and also in the future courses. So if you don't know how to represent a byte, you need to know it. Okay. So now let's talk about how to represent a, a character. As I said, a character takes 1 byte in x86-64. And for characters, we have Ascii encoding to represent different kind of characters. And specifically for character A, letter A, its Ascii number is hex 61. In this case, if you're going to look at the memory will look like this. So this is the higher part, which is 6. So again, like first half, right? So higher half, which is 0, 1, 1, 0, that is 6. And then the lower half is 0, 0, 0, 1. So that is hex 61. This is how they look like in the memory. Okay. Then the question is, what about the string? What will the string look like? So again, we have 2 characters. One is A again, and the other is character B. The ASCII number for A is hex 61 and the ASCII for B is hex 62. And in memory, the first character will store in a lower address and the second character will store in a higher memory address. And that's why if we look at the memory and if we look at left means low and right means high, we will have hex 61 as the first byte. But then remember, when we say 6 or when we say 6, it's actually a higher part in this lower memory address, right? Which means that the 6, if you look at that from the memory, it will be on the right hand side because now right means higher memory and the left means lower memory. And similarly for byte 2, it will occupy the second byte in the higher memory, but within that higher memory location, 6 will be on the higher part, and which is the right hand side, and the 2 will be the left hand side. Okay, and now let's start to talk about integer. What about the integer? Now we know about character, we know about the strings. What will be an integer look like in the memory? So for integer, for x86-64, integer will occupy 4 bytes. So here, when we have 1,100, first let's convert that to a hexadecimal number. And again, as I said, integer has 4 bytes, and those 4 bytes will store from the lower to higher memory address. And here, you need to pay attention because of the, what is called little endian, right? Because of little endian, which is the default setup in x86-64, those bytes will actually store in a reverse way that what we look at, the way that we look at, from the board. So here, when we have this 4 bytes, the least significant byte will go to the lower address. So that's why if we convert the int to the memory, the lower part will be, the first byte will be for C. And then the second byte will be 0, 4. And then the third byte will be this part, and then the fourth byte will be 0 again. So it's like it's sorted in a reverse way. And this is the so-called little endianness. Okay, but then what about a char string, right? We know that in a char string, it's always the first byte comes to the lowest value. So we'll have 4C stores here, 0, 4 stores here, and this vice versa, right? In this case, then if you look at these two, they're all representing the same memory, right? But then because of the type is different, the actual value will be very different. And later on, if you want to convert an integer into a memory, you need to make sure that you follow the little endian assignment, the layout in the memory. Okay, and then if you have, a byte, if you have 4 bytes, you have 4 consecutive bytes in the memory. If you want to convert that to integer, you need to, starting from the 4th byte, put that to the top left as your integer. So you want to reverse it, and then you will have this number, and you then convert it to, a decimal, from a hexadecimal to decimal. Okay, so this is the so-called little endian, and you will need that in the future hex because you need to figure out the memory layout for those arguments storing like in the stack. And then because of little endian, the way that you look at the byte will be different from the way that you look at an integer. But then luckily, Python has this nice wrapping that you don't need to figure out those bytes layout by yourself. But instead, what you could do is just call this so-called struct package with the function called pack. What it's going to do is it will pack this into bytes following little endian routine. So in this function, the right-hand side, the second argument is the integer itself. And then the first argument is the format that you specify to struct.pack. And here, there is a smaller than sign, and the smaller than sign means this is little endian, and I means that it is an integer. So this means that you're going to extend this value to an integer, implying this is 4 bytes, and then follow little endian. Okay. And also similar, if you already have that 4 bytes and you want to convert that 4 bytes into an integer, you could call struct.mpack, and the first argument, again, it is the format. So it is smaller sign little, and I means that it's going to be integer. Okay. And then the next argument of mpack means the string or the bytes that you want to convert. And you can just pass more than 4 bytes. You can pass like 6 bytes or 8 bytes. But if you're going to do that, you will have multiple integers, right? And that's why the output of mpack is an array, or say it is a list. And you want to index it to get the first integer. Because here we have only 4 bytes, and then we know that the first element is what we want, which is the integer. All right. Okay, so those are the knowledge that you need to know about endianness. I also want to just give you like this table. This table states different kinds of a type and different bytes for different kinds of type, and you will need it when you write programs. And in our lecture, we're going to focus on 64-bit sites. You will see that there is a tiny difference between 32 and 64, which is the bytes, the number of bytes for type long. So for x86, a long integer will occupy 4 bytes. And then for 64, a long integer will occupy 8 bytes. So if you are going to have a program in the future, a C program, and you see a long integer in a stack or in a heap, you want to know that this specific integer will occupy for 8 bytes in the memory. Okay. So that's everything about today's lecture. Recall that we learned about how to write, how C's argument passing, the pointer reference, how that works. We also work on a Python client server together. Now you should be able to write a client by yourself that will call the server or connect to a remote server with a specific address and port and interact with them. And then finally, that we talk about the endedness. We talk about how a little endian look like and how that works. You also know this to Python commands that you can call directly to get the right memory layout for different type of argument for different endedness. Okay, that's pretty much for today. Any questions? No? If not, then I'm gonna see you guys next week.